Hi everyone, this is coming to you from Education for All. We are looking at functions and graphs, and we have given the definition of a function as a special mapping such that every element of the domain, input, domain stroke input, is mapped to exactly one element in the codomain, range or output. Because of what other books write, that's why you see codomain, range, output, but they all mean the same thing. But other books would prefer to use one or the other. But you should know that they all mean the same thing. So now, when you have this kind of definition, it means we have different type of mappings that we should be able to identify when we see them. So, this is your domain or input. Mind you, when you have your function f of x is equals to x, or you have y equals 2x plus 1, this is your input. The domain is what we have here as x. I put x here for people to understand, and I put y here. This is your domain, your x. Your codomain or range is your y, if you're looking at functions. And this is the independent variable. Your x is the independent variable, this one here, because it's what you put in. So what you put in, the input, is your independent. What comes out, the output, your y, is the dependent, because what comes out depends on what you put in. So that's why we normally say x is the independent variable and y is the dependent variable. You put in, you get out. Input, output. So this depends on this. Independent, dependent. Right? Okay. So if you have something like this, according to the definition, every element of the domain is mapped to exactly one element of the codomain. When you have this kind of mapping, then we call this one as a one-to-one mapping. 1, 1, 2, 1 mapping. This is how we call this. This is the perfect mapping. Every element of the domain is mapped to exactly one element of the codomain. So what if this is not the case? We have something like this. You have something like this. Now you have two elements of the domain that are mapped to one element of the codomain. Is this a mapping? Two elements of the domain are mapped to one element of the codomain. Is that a mapping? I can say yes, it's a mapping. And what is this type of mapping? This is many-to-one mapping. Many to one mapping. You have many from the x-axis to one on the y-axis mapping. It's a function. Mostly we have this type of functions from quadratic equations. When we start to solve problems, you will see. We have another type of mapping What do we call this type of mapping? This was many to one. What do you call this type of mapping? This type of mapping is called one to many. Because you have one here, one element here is mapped to two elements here. You have one element here, it's mapped to two elements here. So one to many, one to many. And you have another one that is called many to many. It's normally not interesting. You'll come across it, but it's not useful to say in mathematics. It's not useful, but it is there. Many to one, one to many, and they have many to many. I just mentioned it. We'll not do it. So this is the type of mappings that we have. You might be given a problem, and then you will ask to identify the type of mapping and to state whether the mapping is a function or not. That is what we're going to be doing. And in this topic, we've started already, functions and graphs. We're going to be calculating the range, and we're going to be calculating the inverse function as well. As these are functions, they also have the inverse, more or less the reverse function of the functions. Thank you for watching.